Hi all, today's topic is Unit 5 Complex Integration Introduction. First, what do you mean by integral first? Okay, so in this integral, introduction, if f of z is a continuous function for a complex variable, we know that complex variable what it is. Z is nothing but x plus iy. So defined at every point of the curve C whose end point are A and B. When we take a 2 point A and B, when we split the point A to be P naught and somewhere B1, P1, P2, etc. Pn, join all this curve. So the finding of this curve is called as a line integral. It's nothing but single integral over C f of z dz. F of z is continuous function. It is given. So it is continuous means I can write it in the integral form. It's nothing but single integral f of z dz. Z is nothing but complex variable. So that is why we write it in this format. So some curves, what are all the curves we are using in this means contour integral we are using and simple curve we are using and will be using a multiple curve or multiple point. If C is a closed curve, then the point P naught and the point Pn coincide the integral. It's called as a contour integral. So contour integral, how I will differentiate and write means instead of writing a single integral, we have to write like this, phi of integral. Okay, so it is f of z dz. So it can be written in another statement also, an integral along a simple closed curve. When it is a simple closed curve, it is called as a contour integral. So second is a multiple point. If the curve intersect itself at a point from the one point to another, the same point, it's called as a multiple point of the curve. So third is a simple curve, a continuous curve which does not have a point of self-intersection, which will not have an intersection at all. It is a continuous curve. Okay. So another name it is called as a Jordan curve. So these are basics only curve. Okay, so we have so many topics in this. First I will tell overall what are all the topics we are using in this unit. So these are the 5 topics we have to cover in this unit. First topic will be a Cauchy integral formula. Second will be a Taylor's series or Taylor's theorem. Third topic will be a Lorentz series or Lorentz theorem. And fourth will be a Cauchy residue theorem. Before going with the Cauchy residue theorem, we have to learn some basics. So it is nothing but poles, residues, and what are all the types of singular points. There are three types of singular points are there. So if we learn the basics of this only, we can do a Cauchy residue theorem. And the last topic will be a contour integral. So it is nothing but it is the application of the residue. So only according to our syllabus, it is only circle and semicircle. Contour integral application of residue for a real part. So imaginary part also there are so many topics are there. So reduced only we have according to our syllabus only the circle and semicircle. I will give you the definition with respect to the formula in this. Okay, all the definition only the formula related to this in this unit. So first will be a Cauchy integral theorem. So every theorem I have given the statement, full statement. Okay, wherever you go, some in interview purpose or wherever they will be asking what is the full statement, not only the formula. Formula we will be using only for the concept of problem, but we have to learn with only the statement. Proof no need. If f of z is analytic and this if it is differentiable, f dash of z is continuous at all the point inside and on a simple closed curve, then I can write, okay, so it is inside and on a simple closed curve, okay, it is a continuous means, then I can write single integral over f of z dz equal to 0. Okay, so it is only one integral. Okay, it is inside and it is a simple closed curve. It is for a two curves. Then the definition extend. So Cauchy theorem for a multiple connected region. Okay. So f of z is analytic and f dash of z is continuous at all the point in the region bounded by a simple closed curve C1 and C2. When I have two curves, okay. So how can I write it? It means we have to write both first equal to the second curve. So single integral over the curve 1 f of z dz equal to, so integral over C2 and f of z d2. So I will be asking one question. If it is a 3 curve, what happens? Extend it. Okay. So 2 curve it is equal means the third curve also it is equal. If it is 4 curve, x 4 curves are equal. If it is general n curves, all the curves are equal. So like that only it goes on. So third formula is Cauchy integral formula. So Cauchy integral formula, if same f of z is analytic and f dash of z is continuous and one a point will be there. If a is any point inside C, then I can write, okay, so it is inside C, this inside C, I can write f of a equal to 1 by 2 pi I integral over C f of z divided by z minus a dz. Only for a single. Okay, if it is for a general case, okay, if it is every formula we have to know it for general case also. So if fn depending upon your n it varies, okay. So fn of a is nothing but n factorial divided by 2 pi I single integral f of z divided by z minus e the whole power n plus 1 dz. So this is our third set of formula. Fourth is Taylor series. So Taylor's series or Taylor's theorem. So function f of z is analytic at all the point inside the circle C and with its center A and radius R. Then I can write the Taylor series to be, already we have studied this Taylor series, no? So same in your previous semester. That form only it is converted now like this. So f of z is nothing but summation over n equal to 1 to infinity z minus a the whole power n divided by n factorial fn of a, where fn is nothing but it is the nth derivative. F1 means first derivative, F2 means second derivative, etc. It goes on. So fifth will be a Lorentz theorem. If f of z is analytic on two concentric circle C1 and C2 of radii R1 and R2, surely it should be radii 1, it should be greater than R2. Okay. Then I can write a center to be A and on an angular region R bounded by the C1 and C2. Then for all z in R, then I can write the Lorentz series to be f of z equal to sum of an into z minus a the whole power n, sum of bn divided by z minus a the whole power n. Here n equal to 0 here it is 1. Okay, that is the difference. The first part, the whole this first part, it's called as the regular part. The second part is called as a principal part. Special name for that. So what will be our an? An is nothing but, already you know this formula, 1 divided by 2 pi I integral over f of z divided by z minus a the whole power n is n plus 1 dz. So here dn is a principal part, 1 divided by 2 pi I integral over C2 curve to f of z divided by z minus a whole power, only change in this 1 minus n dz. So sixth formula is some poles and residues. So what do you mean by poles? So before going with the poles, there are only two types of poles. Simple pole and poles of order M or N. Okay, different notation in some book M and some book N. Okay, so simple pole is called as a zero pole. Zero pole. So it is a zero pole means when I have something term. Okay, my f of z, I have some terms. Okay, so z square divided by z minus a the whole square. So what is this power? 2 means order 2. If it is power 1 means it is called as a simple pole. Okay, other than 1 every, okay, so no power is there. So it is like a first. Okay, so that is called simple pole. 1, 2, so again 2, 3, 4 everything comes under poles of order M. So simple pole means a zero of an analytic. How to calculate a pole means a zero of analytical function f of z is the value of z for which f of z equal to 0. The given function we have to take it equal to 0. this f of z make equal to 0. I will get one answer, no? So that answer in the denominator. So f of a equal to 0 and f dash when I differentiate I should not get equal to 0. So f of a equal to 0, I get one answer. That answer is called as the simple 4. That answer is called as a simple 4 or 0 4. The same poles of order m is nothing but when I differentiate one time and two time, three time, etc. All if I make it equal to 0, I will get one answer that is called as a pole of order m. So residues, before going with the residues, we should learn what do you mean by singular point. Singular point is nothing but when I make it equal to 0, I get some answer, no. So that answer is called as a singular point. So there are three types of singular point: isolated singular point, unremovable singular point, and essential singular point. So there are three types. So this can be explained in my later video of another topic, singular points. You can check in the residue problem. You can check in this. So the residue at a pole, the same concept. The residue, how can we calculate? Only two types already we have seen: poles, simple pole and order m or n. Okay. So residue is denoted by the symbol r. Residue I need to calculate means I have to denote it by the symbol r. So R is nothing but limit Z tending to Z naught, Z minus Z naught equal to f of Z. When for order n or m, okay, so limit Z tending to Z naught, 1 divided by n minus 1 factorial, d Z d power n minus 1 divided by dz power n minus 1. If order is 2 means we have to differentiate it 1. If it is 3 means differentiate it with respect to 2. Okay, so that is the meaning of this. So respect to this pole and the residues only, your Cauchy residue theorem. So what do you mean by Cauchy residue theorem? Means if f of z is analytic at all the point inside and on a simple closed curve, except for a finite number of the isolated singular point. Okay, except at a finite number of isolated singular points, that is z1, z2, etc. within a curve C means, then I can write a Cauchy residue theorem. It's single integral over f of z dz is nothing but 2 pi a into sum of the residues. I have to calculate each residues and add every residues. I will get the answer for the Cauchy residue theorem. The last topic will be a contour integral. This contour integral is nothing but it is the application. So the application of residues only contour integral. It is named as a contour integral to find only the real integral. Why only the real? Why can't it be a imaginary? Yes, you can calculate. Only according to our syllabus, only it's a real integral. So it is only classification according to our syllabus, only unit circle and semicircle. Unit, what do you mean by unit circle and semicircle means? In the question, when the integration is with respect to 0 to 2 pi, it's unit circle. In the question it's given to be 0 to pi, it's called semicircle. Okay, 0 to 2 pi, the function of, it may be a cos theta or it may be sin theta. The question can be anything. So it may be divide, it may be in the numerator and denominator, both you may have it, anything. Okay, so you don't bother whatever the function given. So into dz, it's called as the contour integral. So for this, what we have to do, it means we have to replace it. Z is nothing but e to the power I theta. So why I theta only? Because general, we know that Z is nothing but R into e to the power I theta is the general format. So why R it's removed means its unit circle means radius 1. Okay, unit circle means radius 1. So that is why Z equal to e to the power I theta. We know that cos theta is nothing but in terms of exponential function, we are able to write this as a formula. No, so e to the power I theta plus e to the power minus I theta divided by 2. So e to the power I theta is now only we have taken Z. So Z plus 1 by Z equal to 2. Same way sin theta can be written e to the power I theta minus e to the power minus I theta divided by 2. Z minus 1 by Z divided by 2i. So you have to write Z equal to e to the power I theta and cos theta equal to Z plus 1 by Z divided by 2 and sin theta Z minus 1 by Z divided by 2i. These three, when I replace it, I will get something. We can do it by a Cauchy residue theorem. So same thing, semicircle, how I can do it means, the concept, what we have to do, change the semicircle to circle itself so that it is easy for me. So how can I convert the given question to circle? Means replace 2 theta is the question. Okay, so 2 theta should be replaced by some other phi. Okay, so when I replace it, 2 into d theta is nothing but d phi. So limit also I will change. Limit is given in the question, theta equal to 0 and theta equal to phi, it is given in the question. Now phi is our new data. Phi is our new data. So phi is nothing but same 0. Pi is nothing but replacing this, pi is nothing but 2 pi. So now you check the question. Before it was the question 0 to pi. Now it is changed to 0 to 2 pi. Now I can do as per this unit circle itself, same concept only. As per the unit circle, only change instead of theta, now replace it with phi. All the question replace it phi. Cos phi, okay, sine phi. Remaining left only will change. Right, it is the same formula only. Related to this will be our next video. Thank you.